Uh, Problem 1 on homework 9 is as shown. Uh, for a parallel plate waveguide, sketch the electric and magnetic field lines for different types of modes. So the first mode is TM1 mode, then we have to draw it for TM2, and then we have to draw it for T3, T2. So I'll just do it for TM1 here. You can repeat the same thing for TM2 and TE2. How does this work? I've drawn here a parallel plate waveguide. So this is the upper plate and this is the lower plate. Okay. Now I've also marked the beta z here and the y by b here. So this is the y direction and this is the z direction. Now, how do you go about drawing it is basically you start writing down the equations for the electric and magnetic fields. So what are the electric and magnetic fields? The electric field has two components. One is the EZ component, okay, which is y comma z comma t, which is equals to some constant a1 sine n pi y by b multiplied with cos omega t minus beta z. Similarly, we have electric field in the y direction, which is given by beta b by pi a1 cos pi y by b multiplied with sine omega t minus beta z. And finally, we have hx y comma z comma t is equals to minus omega epsilon b by pi a1 cos pi y by b sine omega t minus beta z. Okay, so in all these cases, because we are solving for t, so I just have to put in n here and n here. Okay, yeah. So for the first problem, A is TM1, which implies n is equals to 1. Now, all that we have to do is we will solve for these equations at different places in this waveguide. Let's say at 0, at pi by 2, at pi 3 pi by 2 and 2 pi, and see how things look, and from there on use our imagination to basically draw the lines, field lines. Okay, so how do we do that? We could do this in a number of ways. The simplest way, of course, is to set the time equals to 0. Okay, let's set t is equals to 0, because that simplifies a lot of these equations, because cos of omega t minus beta z becomes cos minus beta z, sine omega t minus beta z becomes sine minus beta z. So all of them become simplified. Okay, we could do it at other times, but this is the simplest solution. Okay, so t is equals to 0 and n is equals to 1. Okay, then we'll first try and see what happens at, say, at y is equals to 0 and y by b is equals to 0 and beta z is equals to 0. Okay, when you do this, practically all that you're trying to do is you're trying to solve for all these three equations there. So electric field has only z and y components, magnetic field has only x components. So at all of these values, you will see that Ez is going to be, so you see if y by b is equals to 0, then Ez is equals to 0. Ey is again going to be equal to 0 because sine beta z is equals to 0. And hx is also going to be equal to 0 because this is 0. Okay, so we have nothing, no magnetic field or electric field at this point. Okay, now let's try at t is equals to 0, n is equals to 1, y by b is equals to b by 2. Okay, which is y by b is equals to, let's say, half. Okay, and beta z is still equals to 0. Now what do we get? We get Ez equals sine pi by 2. So that's 1, and that will be basically cos 0 is again 1, so it'll be a1. Okay, just apply these values to the equation here, and you'll find what I'm trying to say. And ey would be some beta b by pi a1 multiplied with cos pi by 2, so which is 0. So this entire thing is multiplied with a 0, so it becomes 0. What happens to hx? Hx is again has a cos pi by 2 term, so it basically becomes 0. Okay, so what do we understand from here? That at y by b is equals to half and beta z is equals to 0, we have an z component only. So let's go ahead and draw the z component. Okay, so and let's make the line a bit thicker. So there is a field line like this. Okay, let's try for t is equals to 0, n is equals to 1, y by b is equals to 0, and beta z is equals to pi by 2. Okay, now you will get Ez equals 0, Ey equals some value because it's cos 0 and sine pi by 2, so this will have some value, and hx is again going to have some value, okay, which is basically a1 cos 0 is 1, again sine 90, that's sine pi by 2 is 90, which is, so it's going to be positive. Okay, so what does it say? Basically it means up here, here the field is going to go into the plane, because that's the x direction. Okay, so here you have an x positive direction, because this negative and the negative coming out of here will basically multiply and make it positive. So the field here is going to go positive. And what happens to the ey component? Ey component is going to be in the let's see what happened to the ey component. Ey component is going to be negative because there is a sign minus pi by 2, so it's going to be in the so we will have our field in this direction. Okay, similarly we'll get at this point when we change y by b equals to 1, we'll get electric field like that. Now similarly you will have you'll get that the field is going to be like this at pi. Now all that you have to do now is use your imagination to basically sort it out from here on. So what we end up doing is, the same line cannot go to both the ends, so we'll start drawing two different lines which basically vary like this. Okay, so you have one field line going like this, again another field line that's going like this. So once you understand this concept, you pretty much can replicate it over here, here, and everything. So all that I need is a bunch of lines like this. Maybe if you're not yet sure, it'll look something like this here, and so it'll be like just to finish the entire picture, it's going to be like this and like this. So basically you will be like this, and then it'll be like this. Okay, that's about it. Thank you.